Okay, as discussed in our two episodes ago, we're going to talk a little bit about bearings and inspecting bearings. So I have a small collection here. I was going to do a little bit live, but I'm going to have to show you images because there's a conflict, of course. So in any case, at some point I'll get my podcast set up going where I can have multiple feeds. But in this case, Celestron microscope. There's a lot of different types of digital microscopes out there where you don't have to be able to see through the object. So this actually acts as a digital microscope looking down at the object, and we'll see some of those images. I've got a set of bearing parts that we looked at, or that I caught data on, and we're going to show that next. And then there's a whole history of stuff. I'm going to randomly select a few and explain what I did. Some of these are wireless, and will connect up to your phone or Bluetooth to your computer or tablet or whatever. This one here I tend to use. I've used it for a really long time. It allows me to, when I'm looking in at objects, it allows me to see some depth just by moving the little dial and then a capture button on top. I have another one of these, and then there's a digital one floating around somewhere that I'll use on occasion if I'm in the field and I need to do an inspection. So let's start out and we'll take a look at a couple of things. So bearings, I usually have an inner race. When I do an inspection, these are ones that we've looked at over time. I will say, okay, I need the outer race of the bearing cut off and then the balls removed and everything else so I can inspect it. So this is an inner race. This is half of an outer race. Let's see if this is don't think this is the other half. No, that's different bearing. Here we go. Two halves of a bearing. Okay, kind of like this. Actually, they're both 6312. These are actually separate bearings. You can see the manufacturer was slightly different. You can see if you can see this, see the slightly larger lip there. But all the other dimensions and angles are pretty much the same. This one here has a bit on the inside. You can see that you have to be careful when it's cut that you don't do too much damage. You see I've got a narrow strip here that widens out here. That means that my load bearing part would have been over here. The next parts, there's a variety of different types of cages that hold the bearings or rollers in place. Let's see a roller one first. I don't have a steel one here because usually people, when they take those out, they don't give me the steel. They just toss those. I don't know why, because I actually need it. This is a phenolic, and you can see there's the rollers that sit inside. That will be part of one of these bearings here, I think. Is it this one? Yep, this bearing here. And you can see there's a lip around the edge here that prevents those rollers from moving. You can also possibly see the marks on the outer part here, and that will going to match up with markings we see on the load portion of that bearing. This tends to be for higher speed or lower temperature instead of a steel cage, which is your average bearing. Another type for high temperature would be this type here. Now this is angled because this would have been in a thrust bearing. And you can see the circles there, so it was taking balls. But this is a brass cage. Those are you'll find those in high load and so on. And this, another type of phenolic, right here, where you can see this particular manufacturer has these inserted. it all depends on what you're looking for. And you can actually see the part of the damage on this one, and there's a number of them that are the same. You can see the bearing started coming apart and is heavily damaged. That's usually lubrication or contamination or loss of clearance. I would need the inner and outer race to see that. I'm also going to show you a little bit on what we do when we're looking at coils. Right, so this is that black wrapping there, that is for dielectric. So this coil would be in a machine that's over 6,000 volts. This would be probably 4160 or 2300 volts, smaller machine, and so on. And I've got a couple of these where I've taken some images so you can see end down, because what we'll do is we'll use a microscope to look and see if everything's filled or not when we're looking at those. This is one that we were peeling back. This was an investigation I did a paper on, and this is mica tape here, and we were actually following through, there's some right there. We're following through little bits of iron that were eating their way through that material. So let's go ahead and we'll start. This here is the outer race of this first one, okay? And you can note on the outside, this is fretting, and fretting occurs when the bearing is basically moving a little bit in the housing. Now, some people say, oh, that's just straight rust. No, rust is a little bit of it. It will rust, but fretting actually has to occur through some type of movement in a housing, usually a loose housing, or if the bearings are catching. So, and then you can see there's a lip here where there's nothing, and then right here. So that means that this bearing was not fully inside the slot. Turn off the sound there. Was not fully inside the slot, and therefore we have this marking. Now that's important to note that, because a bearing needs to be fully in a housing in order to provide good loading for the balls themselves. Otherwise, even if this is a pilot, or meaning a bearing that's just keeping a rotor in position, it's eventually going to move a lot because a little bit of that bearing is outside of the housing and cause it to loosen up. So first thing I do when I cut it is I'll look inside. Really, it's hard to tell what's going on there. What I also want to do is you take a little bit of paper towel. Actually, lint-free is best, so a lint-free towel is best because you'll see some lint in some of these images. Now, it's still hard to see what's going on, even with a spyglass, so even if I take a quick look at that, so microscope, even at 10 time, a little bit of I should have paid attention to that. There's lights on that one. It's not dimmable, but this one here has a very light discharge pattern. We'll see what more of those look like. So that's the first bearing. You have to be careful when you're doing it. Angle it around so you can get a good shot. Next one will be the roller bearing housing. This is part of it. There's pieces in there, and it's hard to tell if those are when I first go through it, hard to tell if those are bits and pieces or not. But what I look for is if they're evenly spaced. So I have some evenly spaced spots. That usually refers to false brinelling. Okay. Guess I didn't get that. That is the next one, I believe. Nope, that is it. So this is the roller bearing. That is basically, it's hard to see here, but that is material starting to raise up. basically it's worn. This is a loading issue. It's actually skidding on the load side. You can tell when you're using the microscope or when you're looking at it. These are the same bearing. Yep, most definitely same bearing. So when I take a look at it, I can see I've got not very much going on here. This side is lightening up here as it comes around. This side is much darker. So this is going to be where the actual load was. You can tell, and it gets wider where the load is. And then you'll also notice that I have this pattern here, and that pattern goes along with, whoops, the pattern I have on these rollers, and there's also some damage on that one. So that tells me that not only was it heavily loaded on that side, but it wasn't aligned properly because I have it more heavily on one side than the other. So either the bearing was cocked a little bit or the machine wasn't aligned properly, which is more probable. So that that's a continuation, and yeah, so those are some of the pieces that we see. This one here, I did not need a microscopic review. This one I don't see that often. Now, even when we get water ingress into a bearing, we generally don't see rust occurring inside the bearing itself. Chances are this was not stored properly, and the bearing had rusted. That's actually what it kind of looks like, because it looks like afterwards the ball had gone around and cleared up a lot of that rust. Outside looks perfectly fine. It was a good fit and everything else, but that would definitely be a problem and a reason for noise in a bearing. So let's see what we have here. Okay, that is that bearing. Let's take a look at the next one. So this one, at first, when you look at it, now people always say that if I have electrical discharge, I must have that ladder pattern. Not always. This is an electrical discharge. I know that because of how the marks are. That's a burn mark, by the way. Those are burn marks from arcing. So we had a lot of current sitting there. Some of this isn't a bearing fracture. That's literally just lint left over. But this part here, this is where the ball is running, so that's going to be right here. And you notice narrow, wide, narrow as we go around the inside of the bearing. And that is because of what's called the hysteresis of the bearing. So the bearing will literally broaden out as the load gets heavier and then back off again. So the roller itself actually distorts a little bit. Or the ball, in that case. The inner race of that same bearing, you'll notice a similar pattern, except it's going to be relatively even. You also notice it's shifted to one side. That means that the thrust was kind of that direction. So what I often will do when I have somebody take a bearing apart is I will have them mark where things were located, because if I have it this way and the marks on this side and then on this side, that means it's thrusting like this. That means this bearing is being thrust this way. Now, if this is pointing towards the inside of the machine, that is going to be the growth of the rotor shaft pushing it that way. If it's the other way, it's being pushed back by the load. So things you want to be aware of. So the roller, that one looks, I believe the next one is a roller. Oh, that's the same, that's that bearing. Going from the outside, this is the roller. So this is the inner race, I should say. So this is the inner race of the bearing here. I ignore the white spots there. You're going to move around. This is just lint. That's damage. This is that same one again, looking at it, and you can see that light fuzziness. I don't see any contamination in there. That we'll talk about on another one. This one is a good one. At least it looked like a good one, right? So I'll show you that. Let that catch up. This one here, and you can see actually very, very light marks that are across as it goes around. So this was the opposite drive end of a machine that was having electrical discharge. It's another spot in there, same type of thing. And then finally, for what we were talking about before, this is the classic. Now, you don't need a microscope for this, but at the microscopic level, it looks similar to the other ones, except that it has this pattern. And that just happens to be how the discharge is occurring. And you can see, again, light here, heavy, 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 as this is the load side of the bearing here, and then it'll lighten up as it goes around. So that is a quick view of why we use microscopes for bearing inspections. Now, I'll use that same thing for looking at coils. Now you can see here, and I'll discuss this, we're working on a standard right now. Okay, so that's this one here, and you can't see it there, but that's folded over material that's around each of the coils. So that's basically each of those strands has mica tape around it. So when it was sawed, they got bent over a little bit because I've got a void behind it. So that those themselves are not defects. The voids behind them are, because that's where I'm going to get my little lightning storms or partial discharge. Another good one when I'm looking at roller bearings is sometimes it's a lubrication, other times it's a load issue. Believe it or not, lightly loaded. This one was a lightly loaded roller. You can see the damage as it goes around, and then the spot where it was actually finally dragging. And that's where that squealing noise comes from when you lightly load a roller bearing, is the damage that starts working its way towards this. We see that a lot in electric machines. So let's go back and take a look at some of my history here. Got a lot of different things in here. Those are coils. Let's stick with bearings. Give it a second to catch up. Actually, it looks like that's that shot. This is where a ball is rolling. You can see some contamination tight down. That's false brinelling. So the false brinelling is probably doing some damage to the ball. That's because I didn't wipe it down the greatest. That's just marks. That's that same one. Now this one I know has a little bit of contamination. You see that spot right there. So this is more likely going to be contamination related, because what will happen is sometimes if the contamination, especially metal, gets in between the ball or roller and the race, it gets embedded in the surface. So I'll watch for that. Scratches on the surface. Definite scratch in the surface. That looks like that same bearing. Okay. I'll often take a lot of shots looking for the specific thing, but you can see the reason this looks like this is because the race itself, the material, is starting to come up underneath. There's fractures underneath the surface that are waiting to peel up. Okay, that's oil, and you can see rag material. So I say use a lint-free. This is normal, a little overheated, but normal. This is a false brinelling. Very small. You can just barely see it by eye. And false brinelling is basically there's the ball or roller sitting right there, and the shaft in the motor, if it's installed, is stationary, and everything starts to vibrate, and it basically ends up going back and forth, usually sideways, and will create a mark there. That mark is basically a recessed spot, and as each ball or roller goes by it, it'll damage them until finally it starts lifting this up and damaging the equipment more. Scratches on the surface or leftover material. Again, same type of thing. You can just see those fractures. Those fractures are basically just starting to show on the surface. Those are below the surface, or the result of below the surface, just like these here. This is interesting. I remember this one. It's a combination of things going on here. One of those is is discharge, but you also have a discharge on a soft start. So it's discharging periodically, but not like the other ones that'll be on a drive. So we'll see that once in a while on soft starts where they're started a lot, and you have the ability to have shaft currents. I think this one was really exciting because we had a whole 60 volts present on the shaft. We had a technician actually get a little bit of a jolt from it. You always want to be careful. Never touch something that's operating. But he went in to touch the thing with a regular multimeter probe, which you don't want to do either. There's different kits, and you want to use an oscilloscope to detect some of this stuff. We'll talk about that in the next one. Just aged and misaligned. Some false brinelling and general wear, meaning that it's aged. Same thing, this is contamination. So basically, contamination got into the bearing itself, between the ball in this case and the equipment. And we're back to where we were. So that's a quick overview. Now, what's really kind of important is understanding that a lot of this material is available. There's a couple of options I like to use. One is SKF, and everybody else has a chart for detection of faults. But I also have in my library this book here called Rolling Bearings Handbook and Troubleshooting Guide. Basically, it's neutral, if you know what I mean. So it'll have different types of failures and what they look like. Excellent book, not cheap. I got this from the Vibration Institute. I believe it's also available on Amazon, but there's a couple of books like it that provide guidance. I usually, we started doing our own investigations back when I was with the repair shop, primarily because, well, every time we'd send something out like this, it was always lubrication or something like that. And so we started doing our own investigations, went through some training with a couple of bearing manufacturers for certifications, and then started using our own work in order to help determine the root cause. I mean, we can infer different things going on in the application based upon what's going on with the bearings. Had a few, as a matter of fact, where we use ESA and we detect a problem, then we get the bearings back after. If you've seen some of my presentations, including one on the detection of a bearing issue and a thrust issue in a wind turbine, That was a very large bearing, a 6330, so that was about, yay big around. And a ball bearing, yay big around, it was heavy. In any case, we were able to see the false brinelling on the inner and outer race, the amount of losses associated with those, and then some of the dragging from some of the balls because of the improper thrust because of a missing spacer in the coupling. So with that, we will see you next week. Haven't figured out a topic yet. It's going to depend on some things we're working on this week that are quite exciting. And we will talk about those then. Possibly even discuss a few standards things. Unfortunately, this year I wasn't able to make it to Seagray in Paris for a lot of reasons, but in any case, I will be remote in on some of the discussions. So we'll talk about those next week.